Now, after getting armed with the knowledge of interconversion between hexadecimal and the binary, we can start with the bitwise operators in embedded C. There are basically 5 different bit operators: bitwise OR operator, bitwise AND operator, bitwise complement or negation operator, bitwise right shift and left shift operator, and the last one is the bitwise XOR operator. Let's start with AND operator. Binary AND operator in embedded C is denoted by this ampersand sign. This is nothing but the truth table of AND operator. If we consider A and B are two input and Y is the output, if A is 0, B is 0, output is 0. If A is 0, B is 1, output is again 0. If A is 1, B is 0, then output is 0. If A is 1, B is 1, then output is 1. In simpler way, you can remember it like this. Whenever you AND 0 with X, X can be 0 or 1, the output is 0. Whenever you AND 1 with X, the output is always X. Let's consider variable A, B and C. All three are unsigned character type. A equals to 0 cross 66. It's a hexadecimal notation of this number. Similarly, B equals to 0 cross B3, which is the hexadecimal number of this number. If we do AND operation on these two variables, and if we collect result on C variable, you will find the output in C is 0 0 1 0 0 0 1 0, that is 0 cross 2 2. The first bit of A is AND with first bit of B, second bit of A AND with second bit of B, and so on. So if we AND this, 0 AND with 1 is 0, 1 AND with 1 is 1, 1 AND with 0 is 0, and so on, we get output C equals to 0 cross 2 2. The next one is OR operator. OR operator in embedded C is denoted by this sign. Truth table for OR operator is, if A and B are two input and Y is the output, then in that case, if A is 0, B is 0, the output will be 0. If A is 0, B is 1, the output is 1. A is 1, output is B is 0, then output is 1. If both are 1, the output is again 1. In simpler way, you can remember it like this. If 1 or with X, the output is always 1, and when 0 or with X, then output is always X. Let's consider we have stored 0 cross 64, this number, in variable A, and 0 cross 10, this hexadecimal number, in variable B. And if you perform OR operation on these two variables, the output will get stored to variable C. Now let's do the OR operation. Here the first bit of A ORed with first bit of B, second bit of A ORed with second bit of B, and so on. So 0 OR with 0 0, 0 OR with 0 0, 1 OR with 0 is 1, 0 OR with 0 is 0, 0 OR with 1 is 1, and so on. To perform this operation or operation, we can take the help of this truth table. After successful OR operation, the value gets stored into C is 0 cross 7 4. Now let's look at XOR operator. XOR also called as exclusive OR operator. In embedded C, exclusive or XOR operator is generated by this sign. Truth table for XOR is this one. If we XOR 0 with 0, output is 0. 0 XOR with 1 is 1. 1 XOR with 0 is 1. And 1 XOR with 1 is 0. In the simpler way, you can remember this truth table like this. If both input are same, the output is 0, and if both input are different, output is 1. Let's consider A, B, C are three unsigned int variables. A hold value 064, B holds 0 cross B3. And if you perform the XOR operation on these two variables, then the output in the variable C is 0 cross D7. You can cross verify the output doing XOR operation bit by bit on these two numbers. 0 XOR with 1 is 1, 0 XOR with 1 is 1, 1 XOR with 0 is 1, 0 XOR with 0 is 0, and so on. The next operator is NOT operator, or also called as a negation operator. In embedded C, negation operator is denoted by this sign. We use this operator whenever we want the complement of any number. That is nothing but if we input is 0, we want output 1, and if input is 1, we want output 0. Let's consider variable A holds value 0 cross 64, and if we apply negation operator on this variable, the output would be 9b. You can cross verify. Just you have to replace 0 with 1 and 1 with 0. Let's see what is shift operators. There are two types of shift operators are present in embedded C. One is right shift operator and the another one is left shift operator. The right operator is denoted by this sign and the left operator is denoted by this sign. A right shift by B. This means the content of register A will get right shifted by B bit positions, and here the content of register A will get left shifted by B bit positions. After right shift or left shift operation, the vacated bits are filled with 0, and we can use these operators to multiply or divide any number by power of 2. Let's consider this example where the content of register A is 0 cross 3b and you are performing left shift operation on this variable by 2 bit positions. Then let's see what will be the content in register B. Again, this operation is performed bit by bit. This bit position 1 is get left shifted by 2, 1 and 2. Similarly, this bit get left shifted by 2, 1 and 2. Hence, if you perform this operation on entire register, you will get content into register B as EC. You can see here, since we are performing the left shift operation by 2 bit position, entire register content are get shifted 2 bit position left side. Hence, these two vacated bits will get filled with 0 and these 2 bit will get discarded. Similarly, you can perform right shift operation. Let's consider the content of register is 0 cross 96 and we are right shifting it by 4 bit positions. Then this one get placed into 1, 2, 3, 4. Here this 0 will get 1, 2, 3, 4 to this position. Hence, the entire content of register A will get right shifted by 4 bit positions. Hence, to the left side of register B, you will get all zeros because these are the empty bit which get filled with 0 value. Since we are right shifting it by 4 bit, this 4 bit will get discarded. You are right shifting means you are dividing number by 2 to the power number of bits, and left shift operation means you are multiplying number by 2 to the power number of bits. Okay, we can cross verify these statements. Since we are shifting the content of register A by 2 position, that means we are multiplying the content of register A by 2 to the power 2, that means 4. We can easily verify these things. Go to calculator, select programmer. Now the content of register A is 3B. Now if I left shifting it by 2, that means I am multiplying it with 2 to the power number of bits, that's nothing but 4. So if I multiply this with 4, you will get EC. And the right shift operation means you are dividing number A by 2 to the power number of bit. That means 2 to the power 4 is 16. Hence we are dividing register or variable content A with 16. The register content of A is 096. Now I have to divide it by 16. So the result is 9. So this is how you can verify.